Welcome to Engineering Math Support. In this video, we are going to see about how to remember the trigonometric functions of some important angles, and also we are going to see about trigonometric functions of allied angles, and I have explained the positive signs of the trigonometric functions in the four quadrants, and some problems you are going to see here based on allied angles with the support of quadrants. Let's move on to the video. So now we are going to see about trigonometry functions of some important angles. To remember the trigonometric functions of angles, I will give the clue like this. I'm going to divide the value 0 to 1 in 4 equal parts. That is 0, 0.25. I'm going to write 0.50 and it is 0.75 and it is 1. Okay, so now I'm going to write this as a fraction form. So it is nothing, 0 only. Here it is 1 by 4 and here it is 1 by 2 and this can be written as 3 by 4. It is 1 only. So now I'm going to write the angles 0 degree and 30 degree and 45 degree. Finally you'll have here 60 degree and this is your 90 degree. So how we are going to remember the sine theta of all the above angles. Similarly cos theta of all the above angles. Similarly tan theta of all the above angles. To remember the sine theta of 0 degree, we have to take root of this value what we are written. Root of what we are written. Now if you take root of 0, so you can write 0 only there. Here if you take square root of 1 by 4, square root of 1 by 4, that is, we know root 4 is 2. So therefore we will have the value 1 by 2 here. Similarly, if you take square root of this 1 by 2, so this is 1 by root 2. Since root of a by b can be written as root a by root b. So applying this, we'll have root 3 by 4. Root of 3 by 4 equal to root 3 divided by root 4 value is 2. So here it is root 1 is 1. To get the cos theta form, just reverse the value and write. So here it is 1 and here it is root 3 by 2 and it is the same place you will get if you reverse, and here you can write 1 by 2 and it is 0. So using the trigonometric ratio, tan equal to sine theta by cos theta. Applying that 0 by 1, applying that 0 by anything is 0. So we'll get the value 0 here. Here we will have sine, that is 1 by 2, whole thing divided by root 3 by 2. We get 2 to cancel. We will have 1 by root 3. The same way 1 by root 2 divided by 1 by root 2, both are same terms, we can cancel and we can write 1. And then here root 3 by 2 divided by 1 by 2. This 2 and this 2 are getting cancelled. Simply we'll get root 3. Anything by 0 is nothing but infinity. So therefore here you will get infinity. So this is the way we can derive this angle table. From here to here we learned. Okay. So now using the trigonometric ratios, what is meant by cot? Cot means 1 by tan theta by reciprocal ratio. So therefore 1 by 0 is infinity. 1 divided by 1 by root 3 is simply root 3, and 1 divided by 1 is 1, and then 1 divided by root 3 is we'll get 1 by root 3, and 1 divided by infinity is 0. Same way we can remember cosecant. Cosecant is nothing but 1 by sine theta. So sine 0, 1 by 0 is infinity. And similarly 1 by 2 is it goes to the numerator and we can write simply 2. Similarly 1 divided by 1 by root 2, it goes to the numerator and write root 2. 1 divided by root 3 by 2, it goes to the numerator and write 2 by root 3, and you will get here 1 divided by 1 is 1. Secant theta. What is secant theta? Secant theta is nothing but 1 by cos theta. So to take this cos value and we are going to write secant value. How we are done in the previous two cases, we are going to do the same. So 1 by cos 0 is 1. So 1 by 1 is 1. Then 1 by root 3 by 2 is 2 by root 3. 1 by root 2 is root 2. And then 1 by 2 is 2. And then 1 by 0 is infinity. So by using the sine theta, cos theta, tan theta angles, we can easily write cot theta, cosecant theta, secant theta angles. Now we are going to see how to find the angles other than this using the allied angle form. Trigonometric ratios of allied angles. What is meant by allied angle? If theta is any angle, then minus theta form as well as n into 90° plus or minus theta are called as allied angles. So sine of minus theta can be written as minus sine theta. The same way we can use it for cosecant, and we can write cosecant of minus theta equal to minus cosecant theta. Cos of minus theta equal to cos theta. The same way we can write secant of minus theta is secant theta. Here the sine of minus theta will emit the sine. Sine will emit the sine and cos will absorb the sine. The same thing, tan of minus theta equal to minus tan theta. How we can write this? We know that it is sine of minus theta divided by cos of minus theta equal to, this is nothing but minus sine theta, and this is nothing but plus cos theta. So therefore minus sine by cos is tan theta minus tan theta. The same thing we can apply it for cot of minus theta equal to minus cot theta. Trigonometric ratios of allied angles in the form of n into 90° plus or minus theta. If theta is an angle, then we can write it in the form of n into 90° plus or minus theta. So based on this n, we are going to divide this category into two forms. If n is odd, what happens? If n is even, what happens? We are going to see it now. If n is odd number, if the number is odd, then change the trigonometric function as follows. How we can change sine in the form of cosine, cosine in the form of sine, tan in the form of cot, cot in the form of tan, secant in the form of cosecant, cosecant in the form of secant, we have to replace. Suppose if the n is even, then you should not change the trigonometric functions. Therefore, the trigonometric functions are as it is. Sine is there, you write sine. Cos is there, cos. Tan is there, tan. Cot is there, cot. Secant is there, secant. Cosecant is there, cosecant. When n is even number, you should not change the trigonometric. Just write the trigonometric term as it is. We are going to write the symbol, the sign. How to write the sign? Put the sign based on the quadrant where the angle lies. For this, you have to use the quadrant concept here. We must have the basic concept in positive sign of trigonometric functions. That is where the trigonometric signs get positive and where the trigonometric form gets negative. That we must know first. Here, this quadrant 1, all the trigonometric forms are positive. That is sine, cos, tan. The same way, reciprocal of that is also positive. Cosecant, secant, cot. Here if you take in the second quadrant, sine and cosecant are only the positive term and remaining terms and all negative form. And in the third quadrant, tan and cot are positive form and remaining terms are negative form. Similarly, fourth quadrant, cos and secant are positive form and remaining and all negative form. What is meant by first quadrant? The angle from 0 to 90 is called first quadrant, and second quadrant is 90 to 180, and the third quadrant is 180 to 270, and the fourth one is 270 to 360. How to remember this quadrant? So here all, so you can keep that as all only. All, it is sine. For S, we should remember silver, and for tan, we can remember it as T, and for cos, we can remember it as cups. So simply we can remember it as all silver T cups. This is the way we can remember the quadrants. If you know this concept, trigonometric function of any angle, we can write. I'm going to find this sine of 135. We know how to write the angle. It is not in the form of negative. It is just like an angle. That angle can be written as n into 90 degree plus or minus theta. I can write this sine 135 as sine of, I can write 1 into 90 degree plus theta. So 135 minus 90 is 45 degree. Okay, by the previous step, here the n value is what? 1. Here the n value is 1 and your theta is 45 degree comparing with this. Okay, so if n is odd, we have to change the trigonometric. That is, sine can be converted as cos. Therefore, the above term can be written as sine 135 degree. Here we can convert that into cos. Here the theta is 45, so I can write cos 45 degree. So now we are going to guess here what symbol has to come based on the quadrant. So it is 1, it is 2, and it is 3, and it is 4. All silver tea cups. Using this, we can remember the signs. So now it is sine 135. Sine of, the angle is sine of 135 degree. So 135 means here it is 90 and here it is 180 and it is 270 and here it is 360. 135 lies here. So therefore this entire value lies in second quadrant. In the second quadrant, which one is positive? Sign is positive. Therefore symbol is positive. So plus cos 45 degree. Using the above table, we can write the value as 1 by root 2. Therefore, sine of 135 degree equal to 1 by root 2. So this is the way we can write the angles other than the table value. Here we can also write this term as sine of 2 into 90 degree. 2 into 90 is 180. So 180 minus 135 will get the same 45 degree. Therefore here I am going to subtract 45 degree. N value is 2 and your theta is 45 degree. So therefore here N is even. Even means no need to change the trigonometry. Therefore sine can be written as sine only. We can write sine of the angle 45 degree and we are going to write what symbol it is. We are going to write the sine 135 lies in what? Second quadrant. Second quadrant sine is positive, so therefore the sine of 135 degree, therefore it is plus. We will get the value as 1 by root 2. You can write on your own method. Either you can write it in the form of positive theta, otherwise you can write it in the form of negative of the theta. You can write and you can find the angles. I'm going to consider another example. Tan of 210 degree, 210. So here I can write that angle given in the form of 2 into 90, that is 180 plus 30 degree. So if you check here, your n value is 2 and theta value is 30 degree. So n value is even. So even means no need to change the trigonometric. Tan can be written as tan only. Therefore tan of 30 degree. So by the quadrant form, we should remember by the quadrants we should find where the angle lies. So it is 90 degree and it is 180 and it is 270 and this is 360. So the angle is given in the form of 210. It lies here. This is all silver tea cups. So here it lies in the third quadrant. Third quadrant, which one is positive? Tan is positive. So here we got tan term only. So therefore the tan is positive. So we know that tan of 30 degrees is 1 by root 3. So finally we can conclude tan of 210 is nothing but 1 by root 3. The same tan 210 degree can be also written as tan 3 into 90, that is 270. I need 210, so therefore if you subtract you will get 60 degree. Here I am going to put minus 60 degree. So now if you observe here, the n value is 3, that is odd, but theta value is 60 degree. N is odd, so change the trigonometric tan in the form of cot. The above term can be written as cot of the angle 60 degree. Now we are going to decide where it lies. Already we have decided the previous method itself. It lies in third quadrant. Third quadrant tan is positive, so here it is positive. Cot 60 degrees is nothing but 1 by root 3. Tan of 210 equal to 1 by root 3. We can derive either in the form of plus theta form or you may derive in the form of minus theta. The way you will get the same result. I hope you learned today how to find trigonometric functions of some angles. See you in the next video. Thank you.